Assalamualaikum and a very good morning to everyone. So today we are going to learn chapter 5, Network in Graph Theory. Now in this chapter there are 5 learning standards to be learned. The first learning standard is to identify and explain a network as a graph. Okay, then the second learning standard is to compare and contrast the directed and undirected graph, the weighted and unweighted graph. Okay. The third learning standard is to identify and draw subgraph and trees, and the fourth learning standard is to represent the information in the form of networks, and the fifth learning standard is to solve problems involving networks. So why must we learn this topic? Okay, it's a part of graph in graph theory. Okay, before this we have learned about graph, about the x-axis and y-axis, where they involve the coordinates. Okay, but in network, okay, what involved is the vertex and the edge. Okay, what is the vertex? Okay, the point here, vertex, and the edge is the straight line that connects two vertices. Okay, now what is the example of use of this network? Okay, you can see the first example. Let's say land transport network. Okay, like LRT, railway station, flight route. Okay, so the vertex will represent the towns, cities, regions, buildings that are linked to each other, while the edge will represent the roads, highway or railway lines. Okay, now the second example of the use of network in social network. Okay, what is the vertex? Like in Facebook, the vertex represents the individuals, okay, maybe groups or organizations. Okay, and the edge will represent the relationships, okay, whether they are friends, colleagues or families. Okay, so network is actually a part of graph that represent some link, or sometimes there are no link to each other. Now, what is the definition of a network? So it's a graph that is denoted by a set of ordered pairs G, V, E, where V is the set of vertices, okay, and E is the set of lines linking each pair of vertices. Okay, now how E is written as, okay, so this is the vertices actually. Okay, A and B are pairs of vertices, and this degree is the number of edges that connect two vertices. Okay, and the sum of degrees will be twice the number of edges. Okay, so this is the formula. Okay, the total sum of degree is twice the number of edges. Okay, so what is degree again? Degree is the number of edges that connect two vertices. Now let's look at an example to make you more understand. Okay, now what do you understand about a simple graph? Okay, what is simple graph? Simple graph is a graph or a network, okay, that has no loops and no multiple edges. Okay, we will see later about a graph that has multiple edges or loops. Okay, for this type of graph, simple graph, there is no loops and no multiple edges. What is the meaning of loops? Loops is like a cycle, okay, where multiple edges means that it is more than one edge. Okay, so for the example 1, based on the simple graph given, determine V and NV, E and NE, and C sum of degrees. Now, if you can remember in set, okay, we have learned in set, what is V? V is a set, so NV is the number of element in the set V. Okay, now if we look at the diagram given here, okay, so what is V? Okay, it should be a set, okay, where the element is 1, 2, 3, 4, 5, 6. Okay, this is for question A. Now NV equals to the number of V. We have 6 elements here. Okay, now how about B? B is the edges. Okay, now how many edges do we have in the diagram? If you can see, the edges is the straight line. Okay, we have 1, 2, 3, 4, 5, 6, 7. So number of edges is 7. Now how do we write the edges? It must be a pair of vertices, okay, because the edge is connecting two vertices. That means when you write the edge, it must be in pairs, okay. For example, 1 connect with 2, okay, that is the first edges here, okay. Now the second edge here is 2 connect with 3, and then 3 with 4, then we also have 2 with 4, okay, this one 2 with 4, then 4 to 5, and then we also have 1 to 5, okay. You can write it in 1 to 1 5 or 5 1, it's the same thing, okay. This one is the same thing, and another one is 5 6, okay. That means they connect the vertices, okay, for edges. Now how about C? Sum of degrees, okay. So degree is the edge that connect two vertices, okay. For example, let's say we take the degree of vertex 5, okay. So the degree for vertex 5, now if you can see 5, okay, for vertex 5, okay, this one is 3 4 and then 2 4, sorry, I've deleted it, okay. Now for vertex 5, okay, what are the edges that connect to vertex 5? Okay, if you can see 1 2 3, okay. So degree for vertex 5 is 3. How about degree for vertex 2? Okay, so we count the edges 1 2 and 3, okay. Can you see it? Wait. Okay, I'll try use the red one. Okay, 1 2 and again 3, okay. So for degree 2, the number of edges are 3. Okay, how about 6? Okay, D6. So we have only one edge, okay, that connect to vertex 6. So for degree for 6 is 1. So the sum of degrees is actually twice the number of edges, okay. Since that we have only 7 number of edges, okay, therefore the sum of degrees the sum of degree equals to 2 multiplied with 7, the number of edges that we got in question B, so equals to 14. Okay, so if you list all the degree for all vertices, in the end when you total up, you sum up the degrees, you will get 14. Okay, so that's how you find the sum of degrees. It's the twice of the number of edges. Okay, so so this is the solution for example just now, okay, the proper one, okay. So you can see V for question A, V and V, then E and E, number of E, then sum of degrees is 14, okay. So here it has listed all the degree for each vertex, okay, and in the end the sum is 14. Next, let's look at example 2. State the number of vertices, edges, and sum of degrees for the following simple graphs. Remember what is simple graph? Simple graph, there is no loop and there is no multiple edges, okay. So for question A, okay, for question A, how many vertices are there? So we have 7 vertices. Number of edges 1 2 3 4 5 6 7, okay, 7. So remember how to find the the edge. Okay, you just count the straight line that connect all the vertices. Okay, how about sum of degrees? Sum of degrees is twice the number of edges. So 2 multiplied by 7 is 14. That is for question A. Now, how about question B? Okay, how many vertices? Okay, we have 1, 2, 3, 4, 5, 6, 7. Okay, 7. And then the number of edges. Okay, count the straight line. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 edges. And again, sum of degrees, we know that the edges is 9. So multiplied with 2, we will get sum of degrees equals to 18. Okay? Okay, now let's look at the second type of graph, that is with multiple edges and loop. Okay, like I said just now, loop is something like a circle like this. Okay, multiple edges means it will connect two vertices. Okay, but it has more than one edge. Okay, so multiple edges involve two vertices. The vertices are connected by more than one edge. Okay, that is the meaning of multiple edges, more than one edge. Okay, then the sum of degrees is twice the number of edges. Okay, this is what we have learned before in simple graph. It's the same thing. Now, how about loops? Yeah, loops involve only one vertex, and the edge is in the form of an arc that starts and ends at the same vertex, like a cycle or a circle. Okay, so each loop adds 2 to the degree. Okay, that means if we have a loop, the degree for that vertex, you must plus 2. Okay, for example, R. If you look at R, okay, look at the vertex R here, the degree for R, okay, we have 1 edge, 2 edge, and plus 1 loop. That means the degree for R is 4, not 3. Okay, because 2 plus, okay, the loop we consider as 2. So equals to 4. Okay, it's not 3 but 4, because 1 loop will represent 2, like 2 edges. Okay, now let the graph given be denoted by a set of ordered pairs again. V equals to A, B, C, D, and then E, the pairs of vertices. Okay, and okay, like given in the diagram. Okay, AB. Okay, so AB, AB. We have 2 AB here. Okay, because we have multiple edges. One is E1 and the other one is E2. Okay, so this is what we call multiple edges, more than one edge. And then we have BC and BC. That means we have more than one edge. Okay, so we have E4 and E5. Sorry, is that E5? E3. Okay, and then CD, no repetition. That means only one edge for CD, E5. Okay, then BD, also no repetition. That means one edge. Okay, so this is BD, E6, and AD also one edge. That is E7, and DD also. This is a loop. Okay, so DD at this start and ends at the same vertex. Okay, so it is a loop. Okay, E8. Now, let's look at example 3. The diagram on the right shows a graph with a loop and multiple edges. State V and NV, B, E and NE, and again see sum of the degrees. Okay, so now let's count on the vertices. Okay, we have 1, 2, 3, 4, 5, 6. So the number of vertices is 6, and the element for the vertices is P, Q, R, S, T, U. Okay, how about age and the number of age. Okay, so we have PQ. Okay, then we have PU, 2PU. Okay, 2PU, because we have multiple ages. Okay, and then QR, QU, 1 age, RS, 1 age, RT, 1 age, SS, the same vertex, that means it's a loop. Okay, then ST, and then TU. Okay, so the number of age supposedly like 9, but remember, loop will represent 2, so we have 10 number of ages. Okay, 8 plus 2, not 8 plus 1, 8 plus 2 goes to 10. So sum of degrees would be twice the number of age, should be 20. Okay, so if you list down all the degree of the vertex, okay, you will get the total is 20. Okay, now let's move to another example. Okay, now we need to draw a simple graph based on the given information. Okay, so the given information is for vertices. Okay, we have 1, 2, 3, 4, 5. Okay, so this one, okay, you can draw anywhere you like. Okay, 3, 4, and 5. Okay, then we have the age. 1 connect with 2. Okay, 1 connect with 2. Then, okay, we read one by one. 1 with 4, okay, and then 1 with 5, then 2 with 3, 2 with 4, and 3 with 4. Okay, so this is an example of a simple graph using the given information. You can also draw a different simple graph. Okay, as long as all the ages, all the vertices are connected with the ages given. Okay, okay, this is for question A. Now, how about question B? Okay, we have P, Q, R, S, T, U. So let's say we write P, Q, R. Let's say I want to write S, T, U here. Okay, so let's do the vertex so that we can connect the age. Okay, so now we have PU. Okay, PU. Okay, and H connect P and U, then PT. Okay, connect with P and T, and then QT, QT, QS. Sorry, QS. Okay, it should be a straight line. Okay, sorry for the this is the vertex. Okay, so QS, and then we have RS. Use your ruler. Okay, RU. Okay, this is my simple graph. Okay, all the age connect the vertices given. Okay, next example 5. Draw a graph with multiple ages and loops based on the given information. Okay, we have multiple ages and loops, so we have to be more careful. Okay, now the vertices given is P for question A, P, Q, R, and S. So P, Q, R, S. Okay, and then now H, PP. Okay, PP. What is the meaning of PP? Okay, PP means that is a loop. Okay, so a loop. Okay, like a circle. And then, okay, PP is a loop. Then PQ, no repetition, that means no multiple edges from P to Q, or Q to P, it's the same thing. So PQ is a straight line. And then PS, okay, P to S, Q to S, or S to Q is the same thing. QS, okay, now we have another edge. You can put it like a curve, okay, or you can also draw the straight line. It's okay. Okay, now we have to QS. Okay, then QR, and then SR, single edge, and RR, again the same vertex, that means it's a loop. Okay, so this is my graph for the graph with multiple edges and loop. Now let's look at question B. Okay, now the vertices are 1, 2, 3, 4, 5 until 7. Okay, so how am I going to do it? Okay, I'll just draw 1, 2, 3, 4, 5, 6. Sorry. Okay, 5, 6, then 7. Where should I write 7? Is it okay here? Okay, let's try 7 here. Okay, now let's draw 1, 6. Okay, we have 2, 1, 6. That means multiple edges. Okay, I want to draw like a curve 1, and another one like a curve also 1. Okay, so 2. Then 2, 7, also multiple edges, 1, 2. Okay, 5, 7. Okay, 5, 7. Okay, 5, 7. Okay, 3, 4. Okay, again multiple edges, 3, 4, 1, 7. Okay, 1, 7, 1 edge, 6, 7 also 1 edge. Okay, 6, 7 also 1 edge, and then 3, 7, 4, 7. 3, 7, 4, 7. So 3, 7 is 1 edge, and 4, 7 is 1 edge. Wow. Okay, not really good. Okay, so you can draw another kind of graph to be more like. Can we try again? Because it's not really, it looks very complicated. Okay, how about we try another one? Since that we can see from the diagram 7, there are more edges that connect with 7. So why not we put 7 in the middle? Okay. So let's put 7 in the middle. 2, 3, okay, and then 4, 5, 6. Okay, let's put 7 here. We will see what will happen. Okay, again 1, 6, 1, 6. Oh, sorry, it should be, sorry, 4, 5, 6. Now just now 1, 6, 1, 6. So 1, 6, 1, 6. Then 2, 7, 2, 7. Okay, 2, 7, 7. And then 5, 7, 5, 7, 5, 7. 3, 4, 3, 4. Okay, 3, 4, 3, 4. And then 1, 7. So 1, 7, 1 each. 6, 7. Okay, 3, 7. Oh, it's a better diagram. and for 7. Okay, I think it's better. Okay, so maybe sometimes when it involves multiple edges and loops, you need to do more than one so that your graph will not that complicated and better. Okay, next, example 6. Determine whether a graph with the following degrees of vertices can be drawn. For A, 3, 2, 2, 1 and 3. Okay, so sum of degrees is 11. So the graph cannot be drawn because the sum of degrees is odd. Why cannot be odd? Because the formula is twice. Twice means you will get an even number. Okay, so the sum of degrees for the second question B, if we total up, we will get 12. So it's an even number. So the graph can be drawn because the sum of degrees is even. Okay. Now, try yourself with practice 5.1a in the textbook, page 134. Do it in your exercise book. And after you do the question, please check with the answer given and mark it. Okay. If you have problems and you get it wrong, so please do correction. Now, what is the difference between a directed graph and undirected graph? Okay, just now, if you remember, there is no direction in our diagram. But here, we will learn, okay, what kind of directed graph and what is not a directed graph or undirected graph. Okay, so a directed graph, okay, a directed graph is a graph in which a direction is assigned to the edge connecting two vertices. Directed graphs are usually used to represent the flow of a certain process. For example, road maps, airlines, networks, electrical circuits, computer networks, and organization charts. Okay, so this is the example of directed graph. If you can see the arrow here, okay, it shows the direction from A to B, from C to B, from A to C. Okay, so for HAB, A is the initial, okay, vertex, and B is the terminal vertex. Okay, it ends at B, so B is the terminal vertex. For HCB, C is the initial and B is the terminal. And for, if you can see, all vertices are connected in one direction only. Okay, now how about undirected graph? Undirected graph is a simple graph or graph with loops and multiple edges drawn without any direction being assigned, just like we did just now. There's no direction, no arrow. Okay, so that is undirected graph. Okay, so diagram 2 shows a directed graph with a loop and multiple edges. Based on the directions of the arrows, it can be seen that, okay, so E4 is from P to R, okay, and E5 is from R to P. You see the difference? Just now when we do 3, 7, 3, 7, doesn't matter, okay, because we have no direction. But when we have a directed graph, okay, the direction is very important. What is the initial, what is the terminal vertex is very important. So like E4, H4, okay, so it must start from P and ends at R. Okay, that is why PR is written, not RP for E4. But for E5, we must write as RP, because why? We start from R and we ends at P. P is the terminal. So we must write E5 as RP, not PR. Okay, now how about E2? E2 is a loop. So we must write QQ. Okay, Q is the initial vertex and also the terminal vertex. Okay, because E2 is a loop. Okay, actually in a loop, we have direction clockwise and anti-clockwise. Okay, that is why the degree for a loop is 2, because we consider clockwise and anti-clockwise. So, but for direction, we cannot write that. Okay, so for a loop, there is no arrow drawn. Okay. Now, this is the differences between directed graphs and undirected graphs. So remember, the learning standard is to compare and contrast directed and undirected graph. Okay, so this is to compare and contrast. For simple graph, okay, what is the difference between undirected and directed graph? Okay, So you can read here. It's the same thing like I just said just now. I explained to you about how we write the edges for undirected graph. It doesn't matter who comes first, who comes later, because of no direction. But for directed graph, how we write the edges, the pair of edges is very important. Okay, what is the initial and which one is the terminal vertex. Okay, that is very important. And the number of degree is the same. Okay, for undirected and directed graph is the same. Okay, and the total of degrees also twice the number of edges. Okay, now how about graph with loops and multiple edges? Okay, so for undirected graph, still it doesn't matter whether you want to write it for multiple edges. You can write it as PQ, PQ or QP, QP. Okay, it doesn't matter. But for directed graph is very important. Okay, whether PQ or QP is different. Okay, it depends on the direction that is drawn in the diagram. Okay, and how about the degree? Okay, the degree remains the same. Okay, for directed and undirected graph. But for loop, okay, if you get the loop, still no direction. Okay, because a loop represents two edges. Okay, the degree is 2. Okay. Okay, now let's look at example 7. Okay, draw a directed graph based on the given information. So we have V equals to PQRSTU. Okay, so the vertices is PQRSTU. Okay, and then the edges is PQ, PR. This is directed graph, so the starting and ending point must be is very important. Okay, you must follow them. So PQ, PR, RQ, SR, SQ, and ST. Okay, so PQ, you can see the direction from P to Q. Okay, from P to Q, and then PR from P to R, RQ, R to Q. Okay, and then SR, S to R. Okay, S to Q, and then S to T. Okay, so there is no edge that connect U. Okay, okay. Now how about B? If you can see the question given, there is a loop at vertex Q, and RS is a multiple edge such that, okay, we are given the degree. Okay, what is the meaning of DE? P, D out P, D in Q, D out Q. Then we are given the value here. What is the meaning of that? Now, D in P means that the edge that into P is 1. Okay, and the D out P, okay, here D out P means, okay, only one edge getting out from P. Okay, if you can look at example here. This is okay, S to P. This is D in P. Okay, and D out P is PQ. Okay, coming out from P. That is D out P. So 1 and 1. Okay, how about Q? D in Q is 3. Okay, and D out Q is 2. Okay, so that means D in Q. Okay, we have 3 edges coming into Q. Okay, so if you can look at PQ, okay, here, this is in Q1, in Q2. Okay, where is another one? Oh, because we have a loop at vertex Q, so another one comes from the loop. Okay, that is D in Q. Now, how about D out Q? Okay, D out Q come out from Q. We have only 2. Okay, because come out from Q is QS, and where is another one? Again, at the loop. Because remember, one loop represents two edges. That means one in and one out. Okay, that is why D out Q is 2. Okay, not 1. Okay. Okay, D in R. How about D in R? D in R, 0. D out R, 3. Okay. So D in R, 0. D in R, degree, that means the degree. Degree in R. I just can't see the degree in R. 0, yes, because from R, there is no edge that is coming into R. Okay. What we have here is going out. Okay, 2 is going out. Okay, and another one here. Okay, 3 is going out. That is why D out is 3, while D in R is 0. Okay. Now, how about S? Okay, D in S equals to 3. So, SS. Okay, so here's the S. D in S equals to 3. Okay, 1, 2, 3. And then D out S equals to 1. Okay, coming out from S only 1. Okay, so this is how you get the diagram. Okay, you just can't simply get the diagram like in given here. Okay, you must do step by step. Okay, first, of course, you need to draw the vertex. Okay, P, Q, R, S. Okay, then we are given RS is a multiple edge. Okay, so RS multiple edge. So you need to draw the multiple edge, and then at Q we have loop. Okay, then only we do the other single edge. Depends on the this one, D in and D out. Okay, I just want to show you how they got the D in and D out. What is the meaning of D in and D out? But to draw the directed graph, first you must follow step by step. Okay, first draw the vertices, and then draw the multiple edges and loop. Okay, and then only you draw the other edge. Okay, that's the single edge. Okay. Okay. Now again,